So, we are back again. So far I have covered things like how to make an enclosure using standard extrusions, and then I also tried to show you a little more about how we end up with having to include a circuit inside one of those enclosures. Now we come to a very bothersome and we can't live easily with them, we cannot live without them condition, that is the connectors. In this case specifically I would like to talk to you about the electronic connectors, which are inevitable. Whenever you need to join two subsystems, we probably end up with this. Now have a look at this screen, have a look at this monitor. I hope you can make out most of these things. Clear. The best part that is clear is that is the same printed circuit board which I have shown you there. Added to that lot of things have been added. There is a beautiful some symbol here and so on and so on. So, and then something else you will see is we are all familiar with this word HDMI. Okay. Similarly, we are all familiar with this terms, that is a USB and so on. So, coming back, you see here this is some device which I do not know, in this case probably it is a wireless device which will communicate with this PCB. Now we end up with a little bit of what you call angelic and demonic this thing, that is this interface. The reality is we need to often remove parts for either servicing or putting it together or replacement or anything. Extreme level is probably have each component going and sitting in its own socket, a little like a wish board. So, I will ignore it, but the reality is when it has to communicate with the outside world, we end up with these connectors. Just taking just this little thing here, you see here there is a some, I won't know what it is, some devices here, and then there is a beautiful connector here. You have seen here there is a something which comes here which sits on top of it. So, you have a, I mean probably type D USB, and then you have a mini USB and all that. Now you know we are why we are here, why we are here. Everything needs power. We are not yet at the place where automatically things can work with gifted power like energy harvesting, but I am sure eventually it will come. Like some of your ID cards and all that, the energy is given, the card itself probably does not need, most of them they have an antenna in the pickup and all that, but the reality is the other side we end up with these power components. In this case it is a 2032 battery, I mean sorry a single cell, a 3 volts cell, internal construction I am not very clear about it. And then one thing you will notice about it is on the cell, I have it here, you see only for convenience sake they have showed you these things and all the circuitry is behind. Now this thing will neatly plug into any place we want. Okay. I won't know it as it says some SCL, SDA, VCC and all, I am only a packaging person. you will notice that this, even the small thing has a 6-pole some connector here, then there is a 4-pole connector here, and the beauty of this whole thing is it also has a socket to take the power. And you should understand that if you see these sockets and all that, you see here, very cleverly made. Top and sides form one pole, bottom forms another pole. So, there is a nice mechanism by which at the bottom there are two spring contacts, it is split. Single contact still has a problem, and at the edge, a longer contact is there because it is there, and the magic is that it fits neatly. Like all other items, manufacturers have spent tremendous amount of effort and energy to get them into this form. If it is just a simple school project, or if you are making the whole enclosure, you can probably buy all these small components and include them in your designs. Alternatively, you must buy cased things. One of the first thing you will notice of any of these connectors, including this beautiful printed circuit board, connector obviously has 2 or 3 things. One of them is those connections to the outside world, another is the shell or the housing which holds it, because in a case like this both are critical, because this part of it is standardized. Any anything which has this USB, I do not know what to call it, I will just loosely call it the USB plug, because the shell is the socket shell. They should be able to take any of those things. So, if you go to their catalog and if you go to the original USB standard given by this thing, maybe you will see that there are beautiful connectors which are built here, which to me it is still a wonder. 2 parts of it is, one is the contact arrangement, the shell, and I am sure this happened to all of you, a polarization to make sure it does not go inside. I am sure it has happened to you. This I have taken from one of the blogs. First time you try, nothing goes inside. You try the other side, then you will notice that does not go. Then you come back in the original thing, it works. And in the process of your trial and error, you have not damaged anything. So, most important on the other side is the way the termination has been carried out. If the standard lead through hole, they have one way of arrangement. In this case, if you see carefully, the outside shell itself is neatly soldered here. So, most of the stress of your trial and error is taken by them. And as I said, tremendous amount of interest and energy is there. I suggest you take a closer look later, or sir, please connect me to this. You have seen such a lot of effort has gone in providing 2 small lugs which will latch on to that small square openings you have here. On the other side, slightly different way of thing is there. The advantage being, it locks in place, absolutely locks in place. There is no doubt about it. And while all this, the outside shell is soldered to it, there is also something. The actual contacts are again lead through hole in the lead type of this thing. Same thing which happens with normal relay mate stacks. So, all of them have a standard pitch. Then on the other side, this contact configuration is required. Now, you come to something which is slightly different. While this is like this, if you see this HDMI connector on this side, the standard thing here is there as much as all the 4 things and all, but on inside the way it is assembled, it still has SMA contacts. So as the substrate or the PWD technology changes, this interface should remain, but the contacts to the other side should change, which is the reality of this. How to make this printed circuit connectors. This I think I have shown you. I have a picture here which if my colleague can kindly show me. Seen this here. This again one more printed circuit board where this header neatly goes and engages with this here. You have seen this, no? This header engages with this. I am not very clear. Luckily, it is not powered. I expect that probably it sits like this. So I won't risk playing with it. Okay. And we also have this, some beautiful power stuff. I do not know whether it goes inside or to me it looks, logically that whole thing will probably fit inside like this. Good. All this has been made possible because of the connectors. And if you recollect, I was trying to show you this, how to make a enclosure using a standard extrusion. You have seen what we have done. We have 4 standoffs which slide through fully. And why is it included here in this connectors thing is, when you assemble all these things together, it is expected that it goes neatly inside and probably sits flush here. You have seen this, no? This is where things help. I have 2 options here. One is I can probably put a small plate here, mount all these things, and then after everything sits inside, try to slide it in, and then you see that I have certain connectors and all on the side also. So I have both options. If I want, when I make the PCB, I can put them here or put the other side and all this. Neat. I am proud that one of our people have done it. Now which will come to something which is both the power as well as thing. Here also, no, what we cannot avoid is these connectors. So if I now try to open this, this is the 18650, it says something 26F ST12 DC2. I have this beautiful battery bank. So this has 2 cells. If I want, if I have to open this, this probably has a single cell. Now the thing is, after all this tremendous effort, everything will be make or break depending on connectors. So if you are lucky, it seems to work, but the reality is it's not a what you call trial and error thing. See, it's still working in spite of my this thing, it's still working. So in a way I am quite happy. Now I will take you something close to things at home. I hope you recollect that I had shown you, sir, please put this camera. Remember I showed you a very unsafe and sad way of our people trying to use a pressing iron. So in the pressing iron, the connectors were exposed, which is a very, very ridiculous thing. But that is old, that is I do not know where we got it or how we got it. All I can say is it was old, old, old. If I go back, I do not know where I kept the pictures, but kindly just be with me. Oh, I missed it here. Wait. I hope you recollect, it's another thing. I will just punch it up. This is a very common, what do you call, clothes iron, or loosely called a steam press. It is not really a steam press. A steam press involved, but then it is a clothes iron. We come to the critical part of it. You see these three pins at the back, they are the ones that will give contact with the base here. See, nicely everything is shielded, you won't see the source of power. Now when I keep it here, it docks neatly and then it charges it. This one, fortunately, it holds the heat directly in the base plate. So, it is a power connector, flat and built into the equipment directly. To me, why I am showing you this is a commonplace thing which you see around, and then carefully if you observe things, there other the metaphorical things is there, and then it has the final ultimate thing. The pitch has been so adjusted, probably during testing, and even if you talk to them, you can probably connect a cord directly this and then try to use it as before. When you want to use it, you can use it as a docked cordless. I won't call it wireless, because wireless generally refers to data communication. Cordless is without the power cord, it tries to work. I feel it is a very innovative and cute, neat design. Now I will move this on to next. Have a look at this. I am sure people have tried various creative uses for it. What we know is that it is a water jug, and you see here there is a beautiful on off switch here, and actually the heating element is built into it down there, that is the heating element. In this here, and this one controls the on off, and also it has the trip thermostat. But the interesting part in this more than anything else is you have a connector here, unlike the 3-pin connector there. It is something which as you dock it, it gets connected, plus you can rotate it in all directions. So, we come to the effective use of coaxial connector. In this case, cable is not coaxial, only the connector part of it is, the two of the pins are axial to each other. And then this is where I thought, no, I should also show you the very innovative way of packaging the whole thing. And then you see here I have a beautiful, what do you call, water heater where this comes out. I can use it for, don't look at my face. Oh, it has to go in, eventually it will go in, okay, right. Now the thing being, why I did it is, you see here how neatly it goes and sits inside, and then after that it rotates here. And the magic is, whenever you try to disconnect something which is on load, they have a chance of sparking. So necessary things of how to prevent sparking. There is not a full-fledged arc chamber as you would find in a contactor, but still all these elements are neatly enclosed here. Now I will come back to the first thing about this again one more time. I would like to acknowledge the trade white papers, and I acknowledge their copyright and that, no. I feel the whole thing is, I am helping both the manufacturers as well as the, what do you call, application engineers who try to use it. But then I cannot give a better summary than what these people have given. So I have a, I will post this separately. I have a huge collection of links which I have just maybe this morning I checked, and they seem to be working. Now coming back to this thing, 2 or 3 things you have noticed. One of the first thing is, you have the electrical requirements, and something a little related to this is the mechanical, and then the safety requirements. Safety, engaging and disengaging, and in the case of various things. Typical electrical requirements are all, I will get back to you. Something related to the basic voltage and current, and occasionally stray capacitance and inductance, and something called the characteristic impedance of it. These are all core electrical requirements. Mechanical requirements are obviously ruggedness, and all non-electrical are included in this, including environmental and shock, vibration, chatter, and then degradation over continuous use. So if you see a contactor like the one that starts these pumps and all that, they are all made for a stated millions of operations, not just 1 or 2. That is the reason they don't fail, not that easily, unless the application guidelines are exceeded. And whenever there is a fire in a building, it is very common in our country to blame, saying it has been caused by electrical short circuit. Me being an electrical person, I would contest it. It is not just accidentally the electrical short circuit has happened. If it was a short circuit, logically the safety devices would have tripped. This is something built on top of it. Typically in a house, I can give you an example. My house is loaded with, I am sorry for avoiding the first person. Houses are often loaded with lots of modern this thing. Like I have that clothes press which is somewhere around 800 watts. I have this which is another 800 watts. Okay, then we have a clothes washer which has an unspecified this thing. Probably it has the water heater is about 1 kilowatt, and then there is an air dryer which takes more kilowatt, and there is a dishwasher which stated power itself is around, peak power is around 2 kilowatts. Then we have a microwave which is a combo microwave which is around a little more than 1 kilowatt. Then we have all sorts of things, and something to really spoil the environment is everything is loaded with air conditioners and refrigerators. But the whole house has only a very small 3 kilowatt connection. So, at maximum we can draw is around 15 amps from the utility, but all these things if you load them together, much more than that. I have around 15-20 kilowatt load. Now, this is where some amount of what you call, something has to be done to make sure that while individually we do not seem to have any issue, together logically something should trip.